Now let's talk about oxidative phosphorylation, which is the final stage of cellular respiration. So this is an overview of all the different steps, and I wanted to show you where oxidative phosphorylation fits in. It is the last stage. Oxidative phosphorylation is the step where all these electrons that were stripped off of these molecules, they're going to end up into this last stage, and then it's going to go through a various number of steps to drive energy and make ATP. And also the electron, the last electron acceptor is oxygen, which is going to make water. So how is it that we can get energy from these electrons to make ATP? How do you convert an energy of an electron into a molecule of ATP? Let's find out. So the electron transport chain have a number of components, and I'm going to go through them one by one, and I'm going to show you how they kind of tie together to help the cell make ATP from electrons. So the first player is the electron transport chain. It is a series of molecules that support oxidation, a set of oxidation reduction reactions. So what happens in here, the NADH and FADH2 deliver these electrons that they're carrying to molecules within the electron transport chain. And these molecules are gonna kind of play a game of relay. When NADH delivers the electrons to these molecules, it goes into a high energy state, and molecules don't really like to be in a high energy state, so they pass it on to the next protein in the chain, and then these proteins then turn the electrons to the next protein and to the next protein, and finally the oxygen catches it. But what is important to see here is that, so NADH and FADH2 deliver these electrons. So what I want you to notice is that some of these molecules that are in the chain, they are also proton pumps, meaning that they have opening in between them to allow positively charged hydrogen ions to move from mitochondrial matrix into the intermembrane space. So as the electron is moving down this chain, it takes these molecules into a higher energy state, and then they pass the electron to the next one, and they go back to their original state, which was lower energy. So what happens to the energy? It's not going to disappear. That energy of going to a high energy state and then coming back is harvested to pump hydrogens against their concentration gradient into the intermembrane space. So that happens as a result of electrons flowing through the chain. And then, as I mentioned, finally oxygen, the final electron acceptor, turns into water. So what is the next player? The next player is an ATP synthase. This is actually the molecule in which ATP is made. ATP is not made in the electron transport chain. It's made by this molecule. So what happens, this molecule utilizes the buildup of hydrogen ions against their concentration gradient, and it also has a protein channel. So when you build up hydrogen ions, they find a way to go back down their concentration gradient. And this is an energy releasing process. And the ATP synthase, which is also referred to as the proton pump, is going to take advantage of this energy releasing step to turn ADP and phosphate into ATP. So now when we put everything together in the step of oxidative phosphorylation, what the cell is allowed to do or is able to do is a process called chemiosmosis. Chemiosmosis means driving a chemical reaction using the energy released by osmosis. So what happens again is that when these electron carriers deliver their electrons to the electron transport chain. The electrons pass through this chain and then allow these molecules to go to a high energy state, then go to a low energy state that releases energy. And as a result, these molecules can pump hydrogen ions against their concentration gradient. If you remember, that's active transport. So now you have a buildup of hydrogen ions in here. You can think of this as a water dam. A water dam stores a lot of water, and then if you allow the water molecules to go back down into a place where they're less concentrated, then there's a lot of energy that is released. So in the intermembrane space, there is a buildup of these hydrogen ions, and they say, hey, there's an opening here. I think I'm going to go back. But since there's a lot of energy built in here, potential energy, then they're going to go down. Energy is released, which allows the ATP synthase to synthesize ATP. So that energy is converted to the energy, chemical energy of ATP. So here's an animation of what the ATP synthase, or what we call protein pump, looks like. In the top, these blue dots in here, these are the protons that are concentrated in the intermembrane space. And as they pass through the proton channel, they turn this molecule around. Actually, if you look at this at a molecular level, you can actually see the molecule turning around. This is the tiniest pump in the entire world. So as it turns around, when the molecule turns around, when the protons go down the channel, it changes the conformation of the molecule down here. This is the active site. This is where ATP is made. Now look down here. You can see that the ADP, that's ADP and phosphate, are going in, and then ATP is coming out. So here's the summary of how much ATP is made at each step. Altogether, approximately from one glucose molecule, we're going to get maximum of 32 ATP per glucose. So in the glycolysis step, we get 2 ATP. In the citric acid cycle, we get 2 ATP. And during oxidative phosphorylation, we get a maximum of 28 ATP. And altogether is maximum of 32. Now, you may see some videos out there or see some other textbook that they're going to give you a higher number than 32. Just don't ignore them. And what you need to do for this course is just to stick with these numbers, and you'll be fine. We also talked about CO2 is being produced from one glucose molecule. We're going to get 2 CO2 at the pyruvate grooving stage and 4 CO2 at the citric acid cycle. Again, per glucose, 4 plus 2, that's 6 carbons that we obtain from this one 6 carbon molecule of glucose. Now I have made this here for you to practice at home and test your own knowledge. You can print this out and put it in front of you and see if you can fill these boxes here with the appropriate information. And really, practice is what's going to help you succeed.